Okay, part 2. Here's a titration problem. Again, you're definitely going to have a titration problem in the written portion, so make sure you know how to do it. There are 2 types of titration problems. You could either be asked to find the volume of something or the molarity of something. It's exactly like what we did in lab on Monday. A lot of you maybe didn't pay attention to all the calculations. You eventually got them done, but I want to make sure you know how to do the calculations, whether I'm asking for a molarity or volume, okay? The problem I have on my board here asks for molarity. So what does this problem say? It's like, what is the molarity of a potassium hydroxide solution if 23.60 milliliters of it neutralizes 20.00 mils of a 0.279 molar phosphoric acid solution? First step, anytime you have a titration problem or any stoichiometry problem, write the balanced equation. Now, sometimes I give you the balanced equation, but if I don't, you better first write it down. So write it down. Potassium hydroxide is going to react with phosphoric acid. Again, this is where the people who don't know anything about nomenclature get tripped up. You've got to know how to create these compounds correctly. And you've had several weeks to learn your nomenclature. So hopefully you're going to be okay. I'm just really, really betting that you took me seriously and you've learned your nomenclature. All right. So these are my reactants. Again, metathesis, double replacement. The potassium is going to go with the phosphate. This forms water, so we're going to form a salt and water. This base, acid, salt, and water. So the salt is potassium phosphate and water. Okay, great. Now we have to balance the equation. You've got 3 potassiums. You put a 3 here. And now we've got 3 OHs, 3 H's. Always think of water as HOH. So if you have 3 H's and 3 OHs, that means 3 waters. So I'm going to put a 3 here. Great. Now it's balanced. All right. If you remember what I told you guys in lab, never ever start with the thing you're looking for. Start with the thing that you know more about. All right. Which one do we know more about? What is the molarity of a potassium? So we don't know the molarity of potassium hydroxide. That's what we're going to try to find. So that means we know more about phosphoric acid. So we're going to start off with phosphoric acid information. Never start with molarity, always start with volume. So neutralize it, 20.00 mils of a 0.279 molar phosphoric acid solution. All right, great. So we're going to start off with the volume of phosphoric acid. I need it in liters so that I can use molarity to cancel out the liters and just end up with moles. So I'm going to move my decimal 3 places to the left, and I'm going to have 0.02000 liters of phosphoric acid, H3PO4. A lot of people don't move the decimal enough places, so be very careful about that. You got to move it 3 places because to convert milliliters to liters, remember you're going to have to divide by 1,000. So move it 3 places. All right, so that's my volume of phosphoric acid. What's my molarity? It's 0.279. So write 0.279 moles of H3PO4 per 1 liter. Great. My liters of phosphoric acid are canceled. Unfortunately, I don't have a lot of room. I wish I was in the lab where I have a big board, but let's keep going here. So bear with me. I'm going to continue the stoichiometry, and the next part is going to just come down here. But for you guys at home, just do it as one long line, okay? Now that I have phosphoric acid, I can relate phosphoric acid to potassium hydroxide through a molar ratio. So we're going to put phosphoric acid down here so I can cancel it out. For every 1 mole of phosphoric acid, it's going to react with what? 3 moles of potassium hydroxide. Okay? Great. Now my phosphoric acid has been canceled. Okay, so I have moles of potassium hydroxide. I have volume of potassium hydroxide. If I put moles over liters, what is that? That is molarity. That's the volume, that's the molarity of the potassium hydroxide that I'm looking for. All right, so I'm going to take this, and a lot of people confuse the volumes. Just read your questions carefully so you don't use the wrong one. So this is the volume of potassium hydroxide. I'm going to put it down here, but I'm going to put it in liters. All right, so I'm going to, again, move the decimal 3 spots. So 0.02360 liters. Okay? 1, 2, okay, good. And then this spot is empty. If it bugs you, just put a 1 there, no big deal. So we have 0.02000 times 0.279 times 3 divided by 0.02360. Okay? All the units cancel, and what you're left with is moles per liter. And moles per liter is molarity. So you get your calculators, you plug it in. Don't forget your scientific calculators for Monday. This times this times this divided by this equals, and round it to the right number of sig figs. How many sig figs? Well, this is 4 sig figs, this is 4 sig figs, but this is only 3. So our final answer has to be 3 sig figs. And if you plug everything in, guys, you will get 0.709 molar to the right number of sig figs, and you are all set. Okay, that is how to do a titration problem that asks for molarity. If the problem asks for volume, it's all the same up to, where's the eraser? Oh, here it is. Up to this last bit right here. So let's say the problem is asking for volume. Then what you would do, they would give you the molarity. So if this problem says, what is the volume of a 6 molar potassium hydroxide solution? So we're going to pretend we have 6 molar KOH. And then we're going to pretend that it's asking for the volume. Everything is still the same. You still write your balanced equation. You still start with the volume of the thing that you know more of. You then use molarity as a conversion factor. So all of those steps are exactly the same. The thing that changes is right at the end. It's asking for volume of potassium hydroxide. They gave you molarity. Okay, remember, molarity is moles per liter. So you're going to flip it over. You're going to write your moles here, 6.00 moles of KOH per 1 liter. So everything's the same. These titration problems are very logical. They all work. This is the setup, but if it's asking for volume, the last thing is you put the molarity, flip it, moles down here, volume here, everything cancels and you end up with volume. Okay? So practice your titration, practice your solubility rules, practice your nomenclature, practice creating net ionic equations, obviously practice stoichiometry, limiting reactant, percent composition, all of that stuff. You have the weekend. What is today? Thursday. You still have, a few days to get all of this stuff done. Okay. Good luck. And I will see you. Email me if you have any issues, guys. All right. Bye.